Yes, today I will be solving partition to k equals some subset problem on LeetCode. So this problem says that we are given an array and a variable k. So we want to find k subset in the array which has equal sum. Since the statement is pretty clear, uh, it is worth noting that the subset problems are basically NP-complete problems, which means that they are non-deterministic and they follows the term complexity of 2 raised to power n. Since it is following 2 raised to power n complexity, it is usually solved using recursion, and it is also non-deterministic, so recursion will be helpful to solve this problem. Okay, so next point to note to solve this problem is that since we want equal subset, we should check whether this total sum of the array is divisible by k or not. If the sum is not divisible by k, then there is no point in finding the subsets because we won't be able to find it. So we'll return false in that case. So we discussed about the basic idea of this problem. Uh, Then we try to explain with the help of a tree. Suppose at the root branch we have a choice to make whether we should add the A1 element to the current subset or we should not add to the current subset. And these choices can be made in the tree for every element. And the depth of the tree goes to the nth element. So if we want to calculate this subset, one of the subset for this problem, then we see that the total sum of the total sum of the array is 20. And if we divide it by k, we get 5. So we want to find a subset which has sum is equal to 5. If we just look at it, we see that 4 is compatible with 1. So if we add 4 to 1, we'll find the subset. Uh, in this case, the A1 is 4 and A7 is 1. So we add 1. So we add the first element in the subset, then we didn't add the second element. So we are going to this root, and we keep on doing this till we find the element which is compatible with the A1. So when we reach the A7, we add the A7 to the subset. So since we are making two choices to add or whether we don't add, so we conclude that the time complexity of uh, subset problems are basically 2 raised to power n, because we are making two choices and the depth of the tree is going till n, and we have to find k subsets. So we multiply the complexity of finding one subset with k. So the total subset of this total time complexity of this problem is k into 2n. Let's see the code of this solution. We try to analyze how the code works. So I've taken sum as 0 and calculate the total sum of the array and check whether this sum is divisible by k or not. If it's not, we'll return false. And here I've taken a visited array which keep tracks whether the element which we have already added in the previous subset is not counted again when we are adding the current element. So when we dive into our recurrence, our recursion, we see that I've taken nums I as the current index, k as the uh, number of partitions, current sum, current number, which means in total number of elements in the current subset, sum which I have divided by k in the recursion, the function call, and listed array. So this is the base case. If we have found it, if we don't have to found, if we don't have any subset to found, then we'll return true, because there is no need to work for when there is no subset. So the next statement is when the current sum is greater than the sum we want to find. So this is the false statement, because there always return false in this case. Now the second case, the third if statement makes the transition to the next state where we have to find the remaining subsets. We see that the current sum is equal to the sum we have to find, and the total number of elements in the subset is greater than 4. Then we will call our function again for recursion with k minus 1, with one less subset to found. So I have started our index with 0, current sum as 0, number of elements as 0. And this for loop is try to calculate the result for every element. For example, when the I is 0, it will run till the end of the tree and find the subset which give this sum we want, and call the recurrence relation for the next subset. So if we are able to find all the subsets, then return true. And yes, when we are including the element, we check whether the element we are currently at is not previously added to the subset. If it has added, then we'll skip this current element and look for the next element, or else we'll visit that element and check for the next element. If by case this recurrence relation return false, then we'll unvisit that element and search for the next element in the subset. So this is the basic idea of this problem, and it is very good problem. Yes, that's it. Practice coding, practice more.